Hi everyone, and welcome to this run-through of Assignment 2 for COMP6991 in 24T1. The assignment is called RSheets, and it'll be implementing a basic spreadsheet kinda like system. Super keen to show this to you. Just quickly while we start, so you know, this is just in the very final stages of being made ready, so I wouldn't be surprised if tomorrow there's some very slight aesthetic changes to the assignment, but the assignment's basically ready for you at this point, and it'll get released at the same time as the lecture on Wednesday of week 8. So let's first of all just quickly talk about spreadsheets for those of you who don't know. So spreadsheets look a lot like this, and the basic idea of them is that you've got cells, and cells can have values. Each cell is addressed by a letter and a number, so this is cell B2, this is cell E3. Cells can contain things like text, they can contain things like numbers, they can also be empty, as you can see here. But one of the interesting things that cells can do, which makes spreadsheets so powerful, is that I can say equals, in this case, and then sum of C1 and D1, or C2 and D2, I should say, and it calculates some extra number. And even better, if I update this number, the dependent number, that is, like the result of this calculation, changes as well. Now, this is super useful in finance. It's useful in keeping track of all sorts of things. I'd be very surprised if people in the course haven't used a spreadsheet or at least seen a spreadsheet before in some context. This is basically the same as what we're going to be implementing. The difference will be that obviously the system we're implementing is a little bit simpler. It uses a command line interface, but apart from that, same idea. Now we always start with talking about goals. The goals of the assignment: get a sense of you using Rust for concurrency, designing and structuring a program, specifically one that's capable of managing concurrent interactions. So you'll need to think about how do you store your data and how do you design the program so that it can deal with these concurrent accesses, and also to have fun making an aesthetic and interesting application. Two things which we aren't trying to do. Number one is to assess your ability to write spreadsheet formula. We've given you a bunch of examples of the spreadsheet formulas that you'll be using. There shouldn't really be much difficulty around using them as well. The language is pretty simple. And also, we're not trying to assess you on writing large amounts of useless craft. This is particularly important for this assignment because there is some writing involved in this assignment, and we'll talk about that more later in this video. But when we're trying to get you to do that writing, it's not because we want you to write hundreds and hundreds of words. We actually want you to write as little as possible as can answer the questions and show that you've thought about the questions that we'll be asking you. So I've already sort of spoken about spreadsheets. I quickly want to talk about Rye. Rye is a language which we are using inside of this program to do the calculations for you. So when in this program you say A1 plus A2, that'll be a calculation. It'll be using this Rye system to do that calculation. You don't really need to know much about it. In fact, you don't need to know anything about it. We've provided code that will do all of this for you. But just to let you know, if you're interested in like how the syntax works, you want to look into it a bit further, we're using that language. Now we've given you starter code, and you have to use the starter code for this assignment. What I'm going to do now is I'm going to talk through, maybe first I'll talk through the library that we've given you, and then I'll show you how that library is used in the starter code. So we've got this RSheet lib here. This is included by the starter code, and it's got 5 different modules, each of which contains some useful stuff for what you'll be doing in the assignment. First one is this cell value module, which contains the cell value enum. Cells in this assignment can be ints, strings, errors, or none. By default, cell value will be none, so every cell is basically considered to be none unless you've set it otherwise. You can set it to be an int or a string. If you do something which Rye considers to be an error, you should return this error type. That's the first part of this. We've then got this cells module here. This is just for convenience in converting from numbers to names and names to numbers. So basically, the cell A, the column A is number 0. We'll basically do that conversion for you. It turns out it's actually not as trivial as it looks. I spent about 2 hours trying to do it correctly, so It's not simple. We've got this command runner here. This is the code that will actually do the RHEI interpretation for you. We've got this command runner struct, which takes in some command. We've got this find variables method, which will come in useful later in the assignment. We've got this run method, which basically runs some command. And you can see an example here. You'll be able to do something like this to take A1 plus A2, given some values, and it'll check, okay, this should be equal to into 15 in this case. So that's the command runner module. We've got the connect module here. This is what manages basically user interaction. There's two ways that a user can interact with your program, either over the terminal or via a TCP connection, so basically over a network. I'll show you that in the context of the starter code. You'll only ever really need to deal with these reader and writer types here. The reader type reads a message from the user and gives you back a string. The writer type, more interestingly, lets you write a message of type reply. And you might say, okay, well, where does that reply enum come from? It comes from the replies module here. And a reply is either going to be a message saying, hey, there's a value. The value is, let's say it's A1. A1 is a integer, for example, or B2 is an error. Or you might send back an error message. That's all of the stuff that we provide in the RSheet lib. I'll show you also what the starter code looks like. So the starter code contains two things: the main function, or the main file, and also a lib file. You're not expected to change this file. In fact, you specifically should not be changing the file. Now, what does this do? It basically takes some arguments, takes an address. This is optional, you probably won't use it, but if you want to use TCP to test your assignment, then you can set this address. It's also got this mark mode variable, and I'll talk about mark mode in a second. We're using envlogger in this assignment. It's a handy little crate that lets you do logging, where you can basically control whether or not it shows up through an environment variable. I'll show you an example of that in the lib file. And what we do is we basically check, okay, have you provided us an address? If you have, then start a connection manager. If you haven't, then just start a terminal manager. And in either case, start a server. And where does that start server function come from? Well, it comes from this module here, or this file here. Here's the start server function. It accepts a new connection. So this is either going to be through a TCP connection or a terminal, doesn't really matter. It prints out using the envlogger system. It just got a message, receives the message, and then writes back out the message, and it returns it as an error. So you just get this string back. This is a really simple sort of takes in an input, will send it right back to you system. And you'll be expected to start with this and then obviously convert it into performing all of the things that the assignment asks you to do. So what does the assignment ask you to do? You might be asking. There are, I believe it's 6 stages. Yes, there are 6 stages. So stage 1 is going to be basic get and set. The idea is if I run the the sample solution sheet, so I can get a variable, say I get A1, that's equal to none. I can set A1, setting it like this is an error. So you might get an error like this. If you say set A1 3 though, that'll work. And then I can get A1 again. And A1 is equal to 3. Now, importantly here, these all happen sequentially. So you have to make sure that you finish this set A1 3 before you let the user run the next command. So there's actually no parallelism here in this stage at all. This is just sort of getting started. So some notes. Let's have a read through. You'll be using the cell running facilities in the command runner module. Given that, you'll be able to run a piece of code. So you might, for example, say set A1 is 3. That's the simplest thing you could do, but you could also say set A1 equals 1 plus 2. And then you'd also expect that A1 is 3. In terms of error handling, if the run command, that is, if the command runner system encounters an error, it'll return a cell value error, and you should treat that just like any other cell value. So for example, if I say set a1 is equal to blah, but blah isn't a real thing, you can see here that we now get this, it's a1 is equal to this error value here. If, however, you get an invalid cell reference, so for example, you say get R2D2, which isn't a real cell, it should send you back an error like this. And similarly, if you send in an entire command that doesn't make sense, you should also return an error. There's some examples here. One other note though, I kind of skimmed over it before, mark mode. So there are auto tests for this assignment, and the way that we're able to do auto tests is through a couple of different things. One of them is that if we set mark mode, we will hide any errors like this that you return. So I'll show you what that looks like. If I run mark mode, and then I say SDF, it says that there's an error, but the exact text of the error gets hidden by mark mode. So you can return whatever error you like, and when we're marking, we just won't look at it. Cool, so that's stage one. It's basically just getting those get and set commands to work in a reasonable way. The next thing you'll need to do is to use variables in calculations. So the simple explanation of what this should look like is if I start a new sheet, I should be able to say set a1 is equal to 1, and then set a2 is equal to a1 plus 1. We'd expect if we get a2, that it's equal to 2. Now, once again, this is still all sequential. There's no parallelism in this stage at all. What you'll be doing is you'll be basically doing these commands once at a time, and we promise you that we will never change any of the cell dependencies. So you never need to worry about us going in and saying set a1 is equal to 3 and then getting a2 again. That's not something we're testing in this stage. It'll change as we go through the assignment, but for the moment, to keep things simple, you can basically just treat variables as constants. There are three types of variables that you should support. Scalar variables, which is just a cell like a1. I might start a new sheet so I can show you. So let's set a1 is equal to 1, set b1 is equal to 1, set a2 is equal to 2, set b2 is equal to 2. So these are all scalar variables. That is, they are there's only one variable in there. I can also have a set c1 to be equal to the sum of a1, b1. And so this is now a vector. It's a list of cells starting at a1 and ending at b1. So if I get c1 now, it's equal to 2. That makes sense. I can also theoretically do set c1 is equal to sum a1 to a2. And if I get c1 now, that's equal to 3. I can even do something like set c2 is equal to sum a1 b2. This is a matrix variable, and basically it covers 2 dimensions. And if I now get c2, c2 is equal to 6. Awesome. Here's an example sheet. Doesn't really matter too much exactly because I've kind of already shown you, but basically you can understand that you get these different sized matrices or vectors. Cool, so that's stage 2. Let's talk stage 3. Stage 3 is where we get interesting. We start having multiple readers and writers. So up to this point, well, you've just been being told, you know, set this, get this, and they've happened in order. Now, we've got this special syntax built into the RSheet library that lets you say something like a colon set a1, 1, b colon get a1. Now, on the terminal, it looks like these are actually coming from the same place. But really what's going on here is that the A1, the set A1 happened on one thread, and the get A1 happened on a different thread. This is particularly useful because it means that you could have 2 different people who are updating and changing the sheet at the same time. This is obviously a little bit silly because it's all happening in the same terminal. This is just for testing purposes. But this is where the TCP connection element comes in. If you wanted to, you could theoretically start up RSheet and then connect to it from 5 different computers. And all of them could perform these set and get commands, and it would work the same way. That's the idea, is that you can now do these multiple connections, and you're going to need to handle the fact that these connections are all separate. So they'll need their own thread possibly you'll need to have these sort of thread, these primitives that can control things across threads, that kind of stuff. Now, one important thing to mention is that because this can now lead to non-deterministic answers, that is, it can lead to a situation where if I say set A1 is equal to 1, and then B says set A1 is equal to 2, especially if these get executed almost at the same time, it's possible that A1 will be equal to either 1 or 2, because it just depends which command executed first. To avoid this, we've got a sleep command. This just sleeps 50 milliseconds. Again, this is implemented for you. You don't need to worry about it. But the idea is that we'll use that sleep command as well as the RI function sleep then, which takes some number of milliseconds and then some value. If I do this. So both of these allow us to basically cause weights to take it from being sort of non-deterministic in terms of whether what variable is equal to what, so that we can test things in a way where, like, we've done something, we've waited half a second, maybe a third of a second, and then done another thing. So in other words, we promise you that all of the test cases we've given will have a correct ordering of outputs. There won't be any non-determinism. You should probably have a think about, okay, how do I handle the fact that maybe I'll get two similar inputs at the same time? But when we're testing, we won't test any cases that do that sort of thing. Cool. That leads us on to stage 4. So you've already done multiple writers and readers. Now what we're going to do is say, well, we might actually change one of the variables that another variable depends on. So for example, if I say set A1 is equal to 1, set A2 is equal to A1 plus 1, in stage 2, we told you we'd never change A1. But now, we might actually update A1 to be equal to 3 and expect that you can calculate correctly that A2 is equal to 4. That's the entire premise of this stage. Now, to make things easier, we do promise you that we're never going to have complicated dependency chains, I should say. And what we mean by that is that for stage 4, you're guaranteed that we're only ever going to have it be so that some variable depends on another variable, and that variable will not itself depend on something else. So it's fine for us to have A2 depend on A1, but in this stage, we're never going to test you on having, say, A3 is equal to A1 plus A2. It's a perfectly reasonable request, but it's not something we'll test you on in this stage, so it hopefully makes things easier. One other important note about this stage is that dependency changes, that is, changes not directly happening in the cell you've set, should happen asynchronously. In other words, they should happen probably on a separate thread, or they shouldn't cause the program to wait in calculating all those other cells. So what do I mean by that? Well, let's say that I set A1 is equal to 1, and then I set A2 is equal to sleep then 10 seconds A1 plus 1. And then I get A2. This is actually going to take a second because it's still executing this command. As we told you before, when you're setting A2, we expect that you complete setting A2 before you start processing the next command. However, so we've set A2 here, and then it takes a couple of seconds for us to get A2. In this case, however, if I now set A1 is equal to 7, we expect that I can now get A1 immediately. I set A1 to 7, that took basically no time at all. I can immediately now get A1. In the background, A2 should still be updating. And so I've waited probably 10 seconds. If I now get A2, it's got the right value. But if I set A1 is equal to 9, and then I immediately get A2, you'll notice that A2 hasn't updated yet. So basically what's happening is that the updates to variables that we haven't explicitly set should happen asynchronously. Now, this also leads us to a complex edge case, which I'm just going to discuss briefly. When you get to this stage, you'll notice that there's a problem because I might choose to set, I'll pull up the example here. I might choose to have one thread set B1 to be equal to A1 plus 1, and then set A1 to be equal to 5 after 5 seconds. I'm then going to set another thread to wait 1 second, and then to set A1 to be equal to 10. Now, at the end of this, if we just ignored these sleep 10s, it's pretty obvious what should happen. B1 is equal to A1 plus 1, okay? A1 is equal to 5. Wait a second, and then A1 is equal to 10. Seems perfectly reasonable. So at the end of this, A1 should be equal to 10, and B1 should be equal to 11. Here's where the problem starts, though. If you don't do this correctly, what might happen is that we set A1 to be equal to 5 after 5 seconds. We set A1 to be equal to 10 after 2 seconds. And so sometime after we've set A1 to be equal to 10, this thread finally finishes and says, oh, don't worry, A1's equal to 5. And if you do that, then A1 will not be correct because you overwrote A1 here, even though it took longer for this to calculate than it took for this to calculate. And there's a timeline written up here that hopefully explains this a little bit better. But the idea is that we've got to be really careful that we respect the latest update and we don't accidentally overwrite later cells with earlier calculations of those cells. Now, it's kind of up to you how you solve this. There's a couple different approaches, but it's a problem that you're going to need to think about. In stage 5, once you've sort of got that sorted, the next thing we ask you to do is to handle multi-layered dependencies. And so at this point, this is sort of the grand finale, really, of the assignment. If I set A1 to be equal to 1, I can set A2 to be equal to A1 plus 1, and then I can set A3 to be equal to A1 plus A2 plus 1. And then if I get A3, it's equal to 4. Why is it equal to 4? Well, because A1 is equal to 1, A2 is equal to A1 plus 1, which is 2, and then we add another 1 to that. And then if I set A1 is equal to 7, and then get A3, it's equal to 16. And why is that? Well, because it's 7, A1 is equal to 7, plus A2, which is equal to 8, plus 1, which is equal to, altogether should be equal to 16. So we basically remove the restriction about only having a single layer of dependencies, and you'll need to handle that correctly. The last part of this assignment, stage 6, is really just handling an edge case that we haven't up to this point asked you to handle, and that is a circular dependency. A circular dependency is something like set A1 is equal to A2. That's fine, even though technically if I get A1, it should be equal to none because A2 doesn't have anything in it. If I now set A2 to be equal to A1, and then I get A1, it says cell A2 is self-referential. In other words, this cell tries to access itself when calculating. Now, that is something you'll need to detect, something you'll need to handle. That's basically it for this stage. So, that's all of the stages of this assignment. The last part of the assignment, from your perspective, once you've done all the stages, is going to be writing these design questions. These design questions are worth 15% of your final mark for the assignment, so they are quite important, and you'll answer them in the markrequest.txt file. Now, the questions kind of loosely correspond to stages, so you'll be able to complete some of these questions even if you haven't completed all of the stages. And what they ask you to do is basically point to a particular piece of code and then leave a short comment about either, could you have done it better, or what would it look like if you did something differently, or explain why you know that, ... The idea behind this is that, number one, tutors will be using this kind of to help navigate around your code and find the important parts of your code. When they're marking, they'll mark these questions, and they may also leave some feedback on these questions or on your code to sort of explain exactly what's going on. The usual sort of other information applies, so around not using crates unless they meet these restrictions, that kind of thing. The other restriction which applies is around plagiarism, all that sort of normal stuff. Don't plagiarize, that kind of thing. Yeah, so that kind of completes the walkthrough of the assignment. I'm just trying to think if there's anything else useful that I can talk about. I might show you a copy of the mark request.txt. That might be handy. It may have changed slightly since we made this one, but we've got basically here is where you'll answer the questions. We'll probably write an auto test to make sure that you don't exceed 150 words and to make sure that you know whether you've answered them or not. The other thing which we've introduced for this assignment is questions to the marker. Now, the idea behind this is that basically we get to week 10, you're really concerned about the exam. Most people sort of get to the end of the assignment and say, I actually, like, whatever. At this point, I've submitted. We want to make sure that if you've got questions or you've got sort of things that you want feedback on, you can ask for that feedback. But we didn't want to just sort of leave a bunch of feedback that then is probably not very useful to you and that a lot of people just don't look at. So if you've got questions about your code, if you've got something you're like, I'm not sure how I would have done this better, or I wish that I'd improved this element, how could I have done that? You can leave those questions here. If you don't have any questions, that's okay. There's no marks for these questions. They are completely optional. There's no marks at all. You can leave it blank and we'll just mark you without sort of doing this, answering these questions. The other thing to note is that we will tell tutors to match the specificity of your questions with the specificity of their answers. If you ask a really general question, we'll give you quite a general answer. If you ask a pretty specific question, we'll try and give you a pretty specific answer. And the reason for that is because, if you ask a question like, how could I make my code better? We might leave some general tips around, you could do this, that, the other thing. But if you say, on line X, I did this, I want to know how I could have done that differently, then your tutor has a lot more context and they're able to give a much better answer. So, please use those if you're interested. And like we said, they're not mandatory. There's no marks for them. They're purely for your learning. So, that's a complete walkthrough of assignment 2. That should be pretty much everything you need to know. We'll probably be adding an FAQ section to the assignment so you can kind of ask questions and we'll put them here. The forum is obviously also open for business, so you're more than welcome to ask questions there. I do hope you enjoyed the assignment. I hope you have a good time with it. And I'll see you at some point soon. Thanks for watching.